Hello, this is question 11 on your June 2022 paper 3 from OCR. It's a mechanics question and where you have a uniform rod, AB, mass 4 kilograms, length 3 meters, rests in a vertical plane with A on rough horizontal ground. So this is rough ground. Particle of mass 1 kilograms, it is attached to the rod at B. Here, the rod makes an angle of 60 degrees with the horizontal and is held in limiting equilibrium by a light insensible string CD, this one. This fixed point vertically above A, and CD makes an angle of 60 degrees with the particle. Distance AC is X, so this distance is X. And we have to find, in terms of G and X, the tension in the string. So I'm going to draw quickly the forces that we have acting on the rod. So we have, I have a mass of 1 kilogram at B, so I have 1G pointing down. Then I have the weight of the rod in the midpoint, because they say is uniform, and it's going to be, well, if that's the midpoint more or less, it's going to be 4 kilograms times G. And then I have the tension in the string pointing that way. And at A, I have a normal reaction pointing up and friction, so the reaction at A, and I have a friction. The rod is not moving, but if I don't have friction, and this is very slippery, this would slip down that way. So the friction is against that tendency of motion. Yeah, is what is stopping it from slipping down. Yeah, so these are the first forces acting on the rod, and I need to find this tension here. So there are a few ways of doing it. This is in a limiting equilibrium, which means resultant force in any direction is 0, and moment about any point is 0. And we can use either or both. If we need to find the tension, I think the fastest way is to take moments about A, because then we don't have RA or friction in the equation, because we don't know them, so we don't want them. If we take moments about A, so I'm taking moments about A, this force G is producing a clockwise moment. So this one is producing clockwise moment. This one about A again is producing clockwise moment. And this one is producing anti-clockwise moment. Yeah, so just have to rotate with the direction of the force. So the moment that these two together produce is going to be equal to this one. So the two clockwise is going to be equal to the anti-clockwise. So my moment is, resultant moment is 0. So let's going to see how we write that. We are going to write moments about A must be 0. So the clockwise equal to the anti-clockwise. The moment that this force produces is the force, which is G times perpendicular distance from, this is the line of the force, so from the point perpendicular to the line of the force, so this distance here. If you look at this triangle, sorry, that's a bit disastrous line. If you look at this right angle triangle, this side is going to be hypotenuse times cos 60. Yeah, because it's adjacent. Hypotenuse is the length of the rod, which is 3 meters. So this length is going to be 3 cos 60. So we are going to write G, which is the force, times the distance, which is 3 cos 60. Then the force that this, the moment that this force produces is, if you look at this triangle, we are going to do exactly the same. The force multiplied by the distance between A, perpendicular to the line of the force. And this side is going to be hypotenuse cos 60. Hypotenuse is half of the rod because it's uniform, and this is the midpoint. So it's going to be 1.5 cos 60 times 4G. So I'm going to do the force, 4G times 1.5, or 3/2 cos 60. So these are the two clockwise forces, and the anti-clockwise, no forces, moment. The anti-clockwise moment is going to be the tension times perpendicular distance from the line, from the point to the line of the force. Yeah, this is the line of the force, and this is the distance. This angle, they don't say, but it's 90. Because if this is 60, this is going to be 30. So up to 90 is 30. This is 60, 30. This must be 90. Yeah, so this is a right angle, which means this distance is x. Yeah, so from A to C is x. And the force is T, is the tension. So this is going to be equal to T times x. And from here, we can write the tension. So the tension is going to be cos 60 is 1/2. So 3 times 1/2, I can write 1.5. So 1.5 g, or I could write 3/2, it doesn't matter. Then cos 60, again, is 1/2. 1/2 times 4 is 2. 2 times 1.5 is 3. So plus 3g divided by x, which is 4.5 g divided by x. Or if you prefer to write as a fraction, we could have 9g divided by 2x. Either way, newtons. Yeah, so we can write either of these two expressions. Yeah, that's the tension in terms of x and g. Then coefficient of friction between the rod and the ground is this one. So they give us new information. Mu coefficient of friction is 9√3 divided by 35. And it says determine the value of x. So this coefficient of friction is going to help us to find this friction. Because it's in limiting equilibrium, the friction is going to be maximum. So we can say that the friction is going to be mu normal reaction. What we need to do is, if we want to find x, the best way could be finding t. So if we use other things to find t, we will substitute t here, and that way very quickly we will find x. So we say, in this case, sum of forces in any direction is going to be 0. So we can use that to find t. We are going to resolve forces horizontally and vertically, because we will need both to find t. So if we resolve vertically, as is in equilibrium, resultant force is going to be 0, or all the forces pointing down are going to be equal to the forces pointing up. Remember, this tension can have, we can write it just finding the components of tension in the vertical direction and the horizontal direction, because I'm going to solve in those two directions. So this this horizontal force, this angle is 30. Why is 30? Because, for example, if you look at if you look at this line, and this line, they are alternate angles. So this is 60, this is 30, this must be 30. Yeah. So this value of t, this component is going to be t cos 30, because this is the adjacent looking at this triangle. And the vertical component, this one, is going to be t sine 30, yeah, because it's the opposite to the angle. So if we resolve forces vertically, we have that g plus 4g is going to be equal to Ra plus t sine 30. So we have g down plus 4g down is going to be t sine 30 up plus Ra. We have 1 and 2 unknowns. That's why we need another equation. Yeah, we can write this slightly better. So we have 5g is going to be t halves, because sine 30 is 1/2, plus Ra. But still we have 2 unknowns. If we resolve horizontally, we have force pointing right is going to be equal to force pointing left. So friction to the right is going to be t cos 30. But we know that the friction, the thing is in limiting equilibrium, the rod, which means the friction is mu normal reaction. We know mu, and we can write this friction in terms of the normal reaction. So we can write this second equation as mu. Mu was 9√3 over 35 times normal reaction is going to be t cos 30 is √3 divided by 2. we can write it cancelling, for example, the root 3. So we have, I'm going to make, so we have this equation, and I want to find t. So it's simultaneous equations, really. It's number 1 and number 2. If I want to find t, what I can do is to make RA the subject here or here and substitute in the other one. Yeah. So if I make RA the subject, for example, in the second one, RA is going to be 35t divided by, so this 35 multiplying, this 9 dividing, so dividing by 18. Yeah, so RA is 35 over 18t. I substitute in this one, and I have that 5g is going to be t halves plus 35 over 18t. I can multiply everything by 18. Yeah, or I can add them first. It really doesn't matter. So there I have 5g is going to be 9 plus 35, 44 divided by 18g. So I can simplify a bit more, and I have 5g is, if I divide by 2, I have 22 divided by 9t, which means that t is from here 9 times 45g divided by 22. This tension is going to be equal to 9g divided by 2x, and from here I can find x. Yeah, I just found the tension that I need. So 9g equal to x, 9g divided by 2x, which means if I cancel, for example, g, I can divide by 9 and multiply by 2 to simplify a bit more. So I can divide by 9 and multiply by 2. So I have 5 over 11 is going to be 1 over x, which means that x is reciprocal of that. So 11 divided by 2, or 2.2 meters. Yeah, which is something that makes sense because this is 3. Yeah, so this x cannot be greater than 3. If we get 5 meters, something is wrong. Yeah, and that's all with this question. There is not a single way of doing this, obviously. We can, so I would say probably the equations that you get are these two, but there are a few ways of finding t. Yeah, or you could even substitute here. Instead of having t, you could have this expression with the x. I just find easier to work with just one letter than work with this whole thing. Yeah, but this is a bit up to you. And that's all.